Hi everyone, welcome back to the another exciting video. So this is the next video in the low level design series, and in this video we are going to cover the second behavioral pattern, which is the strategy pattern. So strategy pattern is widely used where you see the long if else chains. Okay, so wherever you see long if else chains, switch cases, there you can implement the strategy pattern. So strategy pattern is the popular pattern. So that is very important also to know because it solves a lot of problems and real world scenarios. Okay. And in the real world scenarios, you might have seen the strategy pattern implemented. In this video, we will deep dive into the strategy pattern. We will see the theory part. We will see the real world examples, pros, cons, all the things about the strategy pattern. We'll cover all the real world scenarios where you can implement the strategy pattern, and we will take in one example also, and we will try to implement the strategy pattern. And if you guys have any doubt in this series, okay, you can comment it below, and I will try to improve that one also. Okay. And one more thing, the all the code would be pushed on the GitHub repo, so you can check it out. All right guys, without further ado, let's get started into this.
So let's start with this strategy pattern. Okay. So strategy pattern is also a behavioral design pattern in system design. Okay. So let's start with the strategy pattern. So if you see like a long if else chain and switch case statement. Okay. Then there might be a case that you are using the wrong pattern. Okay. You are using if else long if else chain. Okay, and instead of that you can implement the strategy pattern over there. So we will see how we can remove the if else chain with this strategy pattern. Okay, so that would be scalable and that would follow the open closed principle as well as the SRP. Okay, so we'll see how we can implement the strategy pattern. So let's take an problem statement over here. So let's take an example of payment system. So payment system will have the different payment methods, and each payment method will have the different algorithm, correct? So let's say we want to pay via UPI or pay via credit card, debit card. Okay, each payment method will have the different algorithm, but we need to first check like which algorithm we want to apply. Then we will say that if the payment method is credit card, then do this. If payment method is debit card, then do this, etc, etc. So how we can solve this problem? So here strategy pattern comes into the picture. Without strategy pattern, all logic gets tightly coupled. Okay, now we will see how strategy pattern solve this kind of problem. So problem without strategy pattern, we will have the huge if else chains. It will be hard to extend. It will violate the open closed principle and it will be having difficult testing. What do we need? What do we need? We need the algorithms that are encapsulate. Okay, and they should be loosely coupled and they should be separated by each other and switch behavior dynamically at runtime. We don't want to focus on which payment method will come, then do this. We just want to implement the payment. Okay. The user will decide which method they want to pay. Okay. That should be dynamically at runtime. Correct. And we want loose coupling between the context and algorithm. The context here is the making a payment, not which algorithm we are using, correct? So introduction to strategy pattern. So it defines a family of algorithms, encapsulates each one and makes them interchangeable. Correct. So it will have the family of algorithms. It will have the different kind of algorithms. Then strategy pattern will encapsulate all of them and makes them interchangeable dynamically. Correct. So that is the strategy pattern. So strategy pattern structure. So strategy pattern will have a context. Here context is the making the payment. Then we will have the strategy interface, which will allow us to make the payment, and the concrete strategies where we implement the actual algorithm of each payment method. Okay. So let's take an example. This is the strategy interface. So let's take, we have taken the example of payment, right? So here the payment strategy will have the method pay. It will take the amount and it will it just knows like I need to pay only. Concrete strategies will implement how the actual payment will happen. So it will extend or it will implement the payment strategy, and it will implement their own algorithm by themselves. Okay, so here we are implementing the pay method and we are printing just pay via card. So this is credit card. Let's say we are having the UPI payment. This is also a payment strategy. So it should implement the payment strategy and it should implement the pay method, and it will have their own algorithm to pay via UPI. Then the context class is, let's say, where we are using this payment method. So we will have the payment strategy. Then we need to set the strategy. Then we will pass the strategy, correct? The strategy can be of any type, like the UPI, credit card, debit card, anything. Then we are having the user or the shopping cart where we can set the payment strategy by our own. Okay, so it would be a runtime polymorphism. We are defining, it will decide which pay method it should call at the runtime. So this is runtime polymorphism. So let's see how it works. Then user selects the strategy. Okay, user knows which payment method they want to pay. Then context stores the strategy. Then the action will be delegated to their own concrete strategies. Then the concrete strategy will execute that algorithm and make a payment. Benefits of the strategy pattern, like it will provide a runtime flexibility, cleaner code, it will follow the OCP and SRP, and easy testing and debugging. Real world examples we can take over here, like the payment gateways, okay, that we have seen, navigation apps, sorting algorithms, compression utilities, authentication systems. So these all uses the strategy patterns. Let's discuss the pros and cons. So advantages the strategic pattern comes with is the flexible algorithms, reusable code, and better maintainability. Disadvantages of the strategy pattern are like we have to implement many small classes, okay, and client must know like the strategies, which strategies they have implemented and they can use. So these are all the interview questions that you can go through. Okay, strategy versus state pattern. We haven't covered the state pattern, but we will. Why composition over inheritance? How does strategy reduce coupling? Okay, and real world use cases. So strategy patterns encapsulates algorithms, make behavior interchangeable, promotes composition. So the takeaway from this strategy pattern is change behavior without changing context. So we are changing the behavior of the algorithm without changing the context. So this is the theory of the strategy pattern. Now we will try to implement that. Now let's implement that strategy pattern in our IntelliJ. So you will be able to understand in a better way. So first of all, let's create a payment strategy. That would be a interface, correct? So this payment strategy will have the pay method, okay, which will take the amount. Now we will have the multiple types of payment method or concrete payment strategies, which are, let's say, UPI, which will implement the payment strategy, and we need to implement that method with this pay method. Then it will have their own algorithm to pay via UPI. So we'll say paying via UPI. And let's say we are having the new payment strategy as credit card, which will also implement the which will also implement the payment strategy. Will say making payment via credit card. Okay. So now let's say we are having a payment mechanism or payment system. Okay. Which will have a payment strategy. Okay. And it will have a one getter or setter. Correct. Getter and setter for the payment strategy. And it will also have the pay method. Okay. Public void pay, which will take the amount. Correct. And what it will do, it will say this dot payment strategy dot pay the amount. Okay. So this is the payment system that we are having. Now in the client side or the in the main method, in the main class, okay, we are just using the, we'll say main, and now we will have the payment system. Payment system is new payment system, correct? And in this payment system dot, we will say dot set payment strategy is new UPI payment, and we'll say payment system dot pay amount of 10. Okay. Then we'll say payment system dot set payment strategy as new credit card, and now we will say payment method to pay via credit card amount is, let's say, 20. Okay. So this is how we can do. Now let's run this. So it is saying making payment via UPI, making payment via credit card. So this is the example of runtime polymorphism. So this is how you can implement the strategy pattern. Okay. Let's say if we don't have the strategy pattern, then how we will implement this? We will, what we will do? We'll go to payment system. Then here we are having the payment type, okay, or payment strategy. Then we will check if the payment method is type of UPI, then do this. And if we are having the payment type is UPI or other thing like credit card, then do this. So this would be an if else, then it would be a long if else chain, okay, that we solve via strategy pattern. So this code is now following the solid principles. So if we will have the new debit card payment, then what we need to do? We will just need to implement this payment strategy, and they need to implement their pay method by themselves. Okay, so this is how our strategy pattern is implemented. All right, guys, we have completed the second behavioral pattern. Okay, so yeah, that's all for this video, guys. So I will come up with the new behavioral pattern in the next video. Till then, keep learning, keep coding. Okay, so yeah, that's all for this video, guys. I will see you in the next one.